Dear students, we are going to discuss important very short answer questions related to heat and thermodynamics for upcoming intermediate public exams. We will see that the important questions are answered in a simple way. Distinguish between heat and temperature. So what is the difference between heat and temperature? If you write two differences, you will be getting 2 marks. The first one is heat is a form of energy. So heat is a form of energy. So which energy? It is the total energy or total kinetic energy of all the molecules. So simply if you write, it is a form of energy which always goes from high temperature to low temperature. So heat cannot stay at a particular place. It always moves from high temperatures to low temperatures. That is the first definition. Now, what do you mean by temperature? So temperature is the representation of heat. So temperature tells the degree of hotness or coldness. If you write this, that is enough. So temperature tells the degree of hotness or coldness, how much hot a substance is or how much cold an object is. Now the second point is units. So for heat, the SI unit is joule. The CGS unit is erg. The another unit is calorie. Now what about the units? The SI unit of temperature. The SI unit of temperature is Kelvin and the other units degree Celsius, degree Fahrenheit. If you write these 2 points, that is enough. Now second question, what are the lower and upper fixed points in Celsius and in Fahrenheit scales? So we have a thermometer. So let us imagine this as the thermometer. So in thermometers in general we have mercury. So there is a scale. So we have different types of scales of temperature. The lower temperature that can be measured with this is called lower fixed points. And the uppermost reading on the scale is called upper fixed points. Now what are the lower and upper fixed points in the case of Celsius as well as in Fahrenheit scale? That is the question. In the case of Celsius scale, that is in case of degree Celsius, upper fixed point is nothing but the boiling point of water, that is 100 degrees Celsius. And lower fixed point is nothing but the freezing point of water. So water freezes at 0 degrees Celsius. So this is in the case of degree Celsius. In the case of Fahrenheit scale, so this is 32 degree Fahrenheit. That is the freezing point of water. And this is 212 degree Fahrenheit. So in Celsius scale, it is subdivided into 100 divisions, whereas it is divided into 180 divisions. So if you write this much, that is enough. Here 212, 32 and in this case 100 and 0 degrees Celsius. Now third question, can a substance contract on heating? Give an example. In general, when a substance is heated, a solid or a gas or a liquid, when its temperature is raised, that means when it is heated, it undergoes expansion. That is in general what we observe in our daily life. But there are some substances, they contract on heating. They are contrary to our general phenomena. Now what are those substances? The best example is rubber. We know plastic. When you heat them, they contract, they shrink. So only one example is not enough. You have to give 2 to 3 examples. Okay. When water is heated from 0 degrees Celsius to 4 degrees Celsius, instead of expansion, it undergoes contraction. This we call it as anomalous expansion. Anomalous behavior of water. Another example we can give cast iron. So cast iron on heating, its volume decreases. So volume decreases means it is undergoing contraction. Why are gaps left between rails on a railway track? So we see in general, in olden days, there used to be gaps between the two rails. But nowadays, there is a type of welding done in between these two. You don't find any gap. This is a orthodox question. So in summer seasons, temperatures are high. So during summer, this iron rod, that is nothing but the railway track, undergoes expansion. So it expands and even this also expands. So in order to allow thermal expansion, the answer must be to allow thermal expansion. If you write this much, that is enough. In order to allow thermal expansion, a gap is left between two rails. Utensils coated black, and why is the bottom of the utensils made of copper? So if you see a bigger utensil, they are coated with black color. So black is a good absorber of heat or radiation. So a black color coated utensil absorbs more heat. So black is a good absorber of heat, whereas white color is a bad absorber of heat. So it is coated with black color so that it can absorb more heat. In the case of steel utensils, for example, if you have a steel utensil, the bottom will be having additional copper coating or a copper plate. Why? Copper is a good conductor. The answer is, since copper is a good conductor, so it absorbs heat quickly and it distributes evenly. You are supposed to write. Sixth question, ventilators are provided in rooms just below the roof. Why? So nowadays nobody is having ventilators in the rooms of their houses. I don't know why. Suppose this is a room, consider it as a room. So for this room, you will find the windows and doors in the bottom area, and you will find ventilators very near the roof, just below the roof. Why? The hotter air has got less density. So hot gases that come from our breath, or that come from cooking, or that come from other reasons. So whatever the hot air will go out from the room through the ventilators. The cold air is denser, so it comes into the room through windows and through the doors. So ventilators are provided just below the roof because the whole hot air goes and stays near the roof. Because it is lighter, its density is less, it goes up. So in order to escape the hot air, state the different modes of transmission of heat. Which of these require a medium? So heat transfer can take place in three ways. There are three processes through which heat can go from one place to another place. So heat can be transferred in three processes. So one is called conduction. So conduction occurs in solids like metals. Conduction. So a metal rod is placed between a point B, or some solid substance is there in between A and B, so that heat goes from A to B. This is conduction. So a medium is required. Next, the second process or the method of transmission of heat is convection. So convection occurs in liquids and gases. So a medium is required for the heat to pass through. Either you should have a liquid or a gas. The third one is called thermal radiation. So thermal radiation occurs in the form of electromagnetic waves. We know that electromagnetic waves do not require any medium. Which of these require a medium? The second part of the answer is conduction and convection. The roofs of buildings are often painted white during summer. Why? So white is a good reflector or bad absorber of heat. So it is a good reflector of heat energy or radiation. So good reflector or the bad absorber, it doesn't absorb the heat. So when the roof of the home is painted white with white paint, in the summer, people living in this feel cool. Define mean free path. So this comes in kinetic theory of gases. So what do you mean by mean free path? If you take a gas consists innumerable number of molecules, infinite number of molecules, and these molecules are always dynamic. That is the reason why it is called kinetic theory of gases. They are not sitting idle like us. They keep on moving. So each molecule moves. Not only moves, it collides with another particle. So collisions, elastic collisions are continuously occurring among the gas molecules. So what do you mean by mean? Mean is average. Free means without collision. Path means distance. Now the answer is the average distance between the two gas molecules. The average distance between the two gas molecules before they undergo collision. So what is the distance traveled by a gas molecule on an average before it collides with some other gas molecule? When does a real gas behave like an ideal gas? So real gas are the gases what we observe. The gas around us is a real gas. For example, nitrogen and oxygen. Ideal gas does not exist. So what do you mean by an ideal gas? Ideal gas is nothing but a gas which follows Boyle's law and Charles' law and other laws at all the conditions. So that gas is called an ideal gas. So in reality, there is no ideal gas in the universe. A real gas behaves like an ideal gas at a low pressure and at high temperatures. So if you remember LPHT, you can write the answer. This is low pressure and this is high temperature. So this is the condition in which only a real gas can become an ideal gas. State Boyle's law and Charles' law. These are the two gas laws which are famous. You read all these even in chemistry also. So Boyle's law tells the relationship between P and V, that is pressure and volume. Whereas Charles' law deals with volume and temperature and pressure and temperature. There are two Charles' laws. If you write one, that is enough. So according to Boyle's law, for a given mass of a gas at constant temperature, pressure is inversely proportional to volume. So what are constants? The mass of the gas is constant and the temperature of the gas is also constant. So I can write this as PV is equal to constant. If you write this, you will get 1 mark. For a given mass of a gas at a constant temperature, pressure and volumes are inversely proportional to each other. If one increases, automatically the other one decreases. Now Charles' laws, as I told you, there are two. So volume of a gas at constant pressure is directly proportional to its absolute temperature. So while I am dealing with volume, I should keep the pressure as a constant. This is one. The second one, when volume is kept constant, the pressure of the gas is directly proportional to its absolute temperature. So anyone you can write, or this can be written as V over T is a constant quantity, or this can be written as P over T is a constant quantity. Any one of those two. And this one, 1 mark plus 1 mark. State Dalton's law of partial pressure. This is also a chemistry question. For example, I take a cylinder consisting of many gases. For example, hydrogen, nitrogen, oxygen, and etc. Some neon. So it is a mixture of gas. So this mixture of gas exerts some pressure. Suppose it is a cylinder or a balloon, so it will exert some pressure. That is the total pressure. So total pressure of the mixture of the gases is equal to pressures, sum of the pressures of individual gases. In this example, pressure of the hydrogen, pressure of the nitrogen, pressure of the oxygen, pressure of the neon. So what is the definition you are supposed to write? The total pressure exerted by a mixture of gas. The condition is the gases must not react with each other. So non-reacting gases. The total pressure exerted by the mixture of gases is equal to the sum of the partial pressures or the individual pressures exerted by the individual gases. What is the expression between the pressure and kinetic energy of the gas molecules? PV is equal to 1 by 3 mnc square, or this is RMS square, or you can write velocity VRMS square. Now we know that kinetic energy formula is half mv square. Here VRMS square. So kinetic energy is equal to half mv square. So take this equation. So he is asking the relationship between pressure and kinetic energy. So let us write PV is equal to 1 by 3. I'll take 2 by 2. It doesn't matter. So multiplying and dividing. So this is mc square into N. So this can be written as 2 by 3 into 1 by 2 mc square into N. This 1 by 2 mc square is kinetic energy. So this can be written as 2 by 3 Ke into N. Now he is asking the relationship between pressure and kinetic energy. So P is equal to 2 Ke N by 3V. So this is the answer. The absolute temperature of a gas is increased by 3 times. What will be the increase in the RMS velocity of the gas molecules? Now RMS velocity formula is under root 3 RT by M. So from this it is clear that, so it is obvious that any velocity is directly proportional to the square root of the absolute temperature. So initially it is V1. So V1 is equal to some root T, whereas V2 is increased by, the temperature is increased by 3 times, so it is root 3T. V2 is equal to square root of 3T. Now what is asked? The increase, how much it is increased? The increase or the increment in the velocity is given by root 3 minus 1. This is the increase, or this is nothing but 1.732 minus 1. So increment is 0.732. That is the answer. We will discuss short answer questions carrying 4 marks related to heat and kinetic theory of gases. Among those important 4 marks questions, the first one is pendulum clocks generally go fast in winter. So fast in winter and slow in summer. Why? That is the question. So pendulum clock is this type of clock. It is nothing but a simple pendulum. The period of oscillation of a simple pendulum is given by T is equal to 2 pi root L by G. This is the formula. T is equal to 2 pi root L by G. So period of oscillation is directly proportional to the square root of the length. So this is the length. So if length increases, T also increases. So what happens in summer? In summer, due to the high temperature, thermal expansion of pendulum takes place. That means in summer, length of the pendulum increases. When length increases, period of oscillation increases. So it takes much time to complete one oscillation. So T is more means it is taking much time to complete, to execute one oscillation. So that is the reason why in summer it shows slow time. It goes slow. The time will be slow. Whereas in the case of winter, its length decreases. When length decreases, period of oscillation decreases. In a given time, it makes many oscillations. So number of oscillations are increased. So it goes faster. So it goes faster in winter and it goes slower in summer. In what way is the anomalous behavior of water advantageous to aquatic animals? Animals that are living in water like fish or dolphin are called as aquatic animals. Anomalous means typical behavior. What is the typical behavior of water? That is called anomalous expansion. So water, when it is heated from 0 degrees Celsius to 4 degrees Celsius. So in general, the volume of any substance increases on heating. But when temperature is increased on heating, water in between 0 and 4 degrees Celsius, instead of undergoing expansion, it undergoes contraction. And other way around, when it is cooled from 4 degrees Celsius to 0 degrees Celsius, instead of undergoing contraction, it undergoes expansion. Due to this, the density of water is maximum at 4 degrees Celsius. So when I draw a graph between temperature and the density, it will be inverted parabola. So water is having maximum density. That means in one way it is having maximum weight. So in polar regions where the temperatures are very less, 0 degrees Celsius, below 0 degrees Celsius. So when the atmosphere temperature is decreasing, when the atmosphere is cooling down, the water which is at 4 degrees Celsius, as soon as the water gets the temperature of 4 degrees Celsius, it goes down because of its high density. So the lower most layer is at 4 degrees Celsius. Above this, you will have 3 degrees Celsius. Above this, you will have 2 degrees Celsius. Above this, you will have 1 degree Celsius. And the uppermost layer will become ice because of 0 degrees Celsius. So ice floats on the water. In polar regions, the uppermost area only becoming a solid ice. The lower layers, the lower strata of this ocean or the lake is in liquid state, that is nothing but water. This lake, the uppermost layer is ice. So below this layer we have water. So in this water, animals, that is aquatic animals like fish, can sustain. Explain conduction, convection and radiation with examples. We already explained in 2 marks category. So conduction occurs in metals. Metals are nothing but in solids. So mainly in metals. Convection occurs in liquids and in gases. Radiation occurs in vacuum without the help of any medium. So radiation occurs because of the electromagnetic waves. So heat travels from one place to another place in 3 ways. One is conduction, the second process is convection, and the third one is radiation. So in conduction, for example, if you take a metal rod and you heat one of its ends, the heat transfers from one end to another end without the movement of the molecules. So in solid substance, molecules are not moving when the heat is going from this end to this end. Whereas in the case of convection, heat, with the passage of the heat or with the transmission of the heat, the molecules also heat. For example, you boil the water. So when you boil the water, the lower strata molecules, they get the heat energy, they become light, so lighter molecules go up, and the colder one, which are heavier in mass or which are denser, they go down. So in this way, along with the transmission of the heat, molecules are actually moving. In the case of liquids and gases, that process is convection. In the case of radiation, no need of any medium, even in the vacuum. So we are getting the heat energy or thermal radiation from the sun onto our earth. And this is the fastest process, or this is the fastest method of transmission of heat, because heat is traveling with the speed of the light. So which is the slowest one? The slowest one is conduction. So this is the slowest one and this is the fastest one. So this does not require medium. So medium is not necessary. This is a 2 marks question. So medium is necessary for convection as well as for conduction. So we discussed even this question also under very short answer questions category. Explain Celsius and Fahrenheit scales of temperature. Obtain the relationship between Celsius and Fahrenheit scales of temperature. So these are the two different scales of temperature. One is in degree Celsius, the other one is in degree Fahrenheit. So lower fixed point is nothing but the freezing point of water. So freezing point of water. This is the lower fixed point. And both the upper fixed points are nothing but the boiling temperatures or boiling point of water. So in degree Celsius or in Celsius scale, this lower fixed point is taken as 0 degree Celsius. And the upper fixed point, that is nothing but the boiling point of water, is taken as 100 degrees Celsius. Whereas in Fahrenheit scale, the lower fixed point is taken as 32 degree Fahrenheit. And the upper fixed point is 212 degree Fahrenheit. So it is divided into 180 small divisions, whereas it is divided into 100. So 100 centum. So from this, in olden days, Celsius scale used to be called as centi. Centim is 1/100th. So one of these 100 divisions. Now what is the relationship between these two? So relationship is, if you take degree Celsius, C minus lower fixed point divided by upper fixed point minus lower fixed point. This must be equal to any scale. If I take Fahrenheit, this must be F minus lower fixed point divided by upper fixed point minus lower fixed point. So C lower fixed point is 0, upper fixed point is 100 and lower fixed point is 0. This is equal to F minus 32. This is 212 minus 32. So I'll get it as C by 100 is equal to F minus 32 by 180. If you write up to this relationship, you will be getting 4 marks.